Hello and welcome to the Amazon Web Services webcast introducing AWS WAF. My name is Rich Vorwaller and I'll be the moderator for this webcast. I want to thank you for your interest in attending the webcast, and before we begin I would like to walk the audience through a few items. First, on your screen you should see a Q&A pod. During the webcast please feel free to submit any questions you have via the Q&A pod. Our Q&A moderators will answer these questions and select some questions for a presenter to address in the live Q&A session at the end of the webcast. Before we proceed to the live Q&A session, however, there will be 3 poll questions posted in the Q&A pod where we'd like to get your feedback on the webcast content and presentation. Also, today's webcast is being recorded, and we will send all attendees a follow-up email with the URL of the recording and a link to the presentation deck once we've verified video quality. So again, welcome to today's webinar introducing AWS WAF, and thank you for attending. Our presenter today is Nathan Dye, the Software Development Manager for AWS WAF. Nathan has been with AWS since 2010, where he's led several software development teams for both Amazon CloudFront, AWS's Content Delivery Network, and Amazon Route 53, AWS DNS service. Nathan is the author and presenter of numerous reInvent sessions, including topics on web security and DDoS resiliency. He has more than 12 years of experience building and operating internet-scale web services, where he's led multiple teams in developing high availability and high-performance software. With us today, we also have a couple of QA moderators, myself, Rich Vorwaller. I'm the product manager for AWS WAF, and Brian Barker, one of our software development engineers for AWS WAF. Brian and I will engage with you and answer your questions via the Q&A pod throughout the presentation, and we'll reserve some questions for Nathan to answer towards the end. So without any further ado, Nathan, welcome. I'm now going to pass the floor over to you.
Hey, thanks, Rich, for the intro, and thanks again to all the attendees today. It's great to see so much interest in the AWS WAF product. So AWS WAF is a new service that we launched just 3 weeks ago at reInvent. The service is built to help you protect your websites from malicious traffic on the internet. And in today's meeting, we'll go through a few slides and a whole lot of demos with the goal of giving you all the information you need to know in order to get up and running with the AWS WAF. So that includes the initial setup and some examples of configuring AWS WAF to address some common real-world use cases that our customers told us about. And finally, I've got an example that talks about some emerging trends in the web security space and things that we learned about how customers are using automation to improve their web security stance. The webinar today is presented at a 200 level, so the hands-on demos will make sure you don't have to have a lot of prior knowledge about web servers or web security in order to understand what's going on and how to get set up. However, there are a lot of technical details that will fly across the screen, so I'm not going to go into depth on how IP addressing works or HTTP headers or even details on some of the code samples that I'll show, but you don't necessarily need to know all those to understand how we're setting everything up. So first and foremost, when we were figuring out which features we wanted to build into the AWS WAF, we had a lot of conversations with our customers to learn how they were using web security products today. And first and foremost, customers told us that they're using WAF to prevent web application bugs from turning into security breaches. If you followed the news, then you know that bugs in web server software can lead to remote code execution attacks and even data breaches where sensitive information is extracted out of your database out through your web server. And WAFs are an effective tool for blocking bad actors and known bad signatures when they occur. But that's not the only way customers told us they use WAF. In fact, though most customers may buy a WAF to prevent those kinds of security breaches, the day-to-day use cases actually often come back to just stopping abuse cases. For instance, a customer hosting a classified board may be publishing lots of job resumes online that are available for the public to review, or classified job resumes. And But even though they make that publicly available, they don't necessarily want bad actors to come and like bulk download all of their content and publish it on someone else's website. And our customers use WAFs to prevent those use cases. Sometimes bad actors actually just want to bring down a website using web layer requests. And at the web layer, these types of attacks aren't usually the huge traffic volumes that you hear about in the news. These highly targeted attacks may instead go after web pages they know to be resource intensive, like maybe search pages. And they can take down a website with something on the order of 100 requests per second. And customers use WAF to protect against that as well. AWS WAF works by sitting between your website viewers and your web server by running on CloudFront proxy servers. And the goal here is to block all of the bad stuff and let all of the good stuff in. AWS WAF lets you deploy filter conditions that block the requests you specify, and comes with new security monitoring that lets you see when bad requests are hitting your website. Now, these two core functions, the ability to block and to see, and the new monitoring to see what's going on, are really core to WAFs. But customers asked AWS to build something different than traditional WAFs. Customers told us they didn't want the hassle of complex upfront configuration or cost. Traditional WAFs often involve complex network configuration and setup, and sometimes takes days or weeks to get up and running for the first time. And really, customers said they are looking for a set of APIs that can help them leverage the kind of automated tools they've been developing for themselves to automate their web infrastructure alongside their development infrastructure and their production infrastructure. That's because many of our customers have adopted a DevOps model of infrastructure automation. And in many cases, they're managing hundreds of web stacks, and they want to deploy that web security rule set in a fully automated way too. And beyond development automation, the AWS WAFs support what I've seen as an emerging trend in the web security space. So in talking to customers and even internal service teams within Amazon, I saw a really common pattern emerging where customers are building some interesting security automation that looks a lot like what's on the screen. Basically, customers are building tools that ingest a bunch of log data from all their web servers that help them see exactly what users, both good and bad, are doing on their website. And then they develop these threat analysis systems that can identify bad behaviors in all of that traffic and use that information in turn to develop rules to block the bad actors and allow the good stuff to go through. Even Amazon.com uses this method to protect its site against fraudulent activity or bad bots. And the services they use and the APIs that they leverage look a whole lot like AWS WAF. And as another example, one of our private beta customers for AWS WAF was a company called Mapbox. Mapbox builds a service that hosts online maps on the internet that are used in other applications. Their customer is Foursquare, is one specific example, and Foursquare uses their maps to power their application to find out where your friends are, to give you directions to specific sites. And so Mapbox's real asset here are all of the mapping tiles they develop and host. And they're subject to the same kind of abuse we talked about. Sometimes they get a bad actor out there that's requesting all of their mapping tiles in bulk for use offline outside of the Mapbox application system. And they found that by monitoring their web activity, they actually noticed an interesting pattern when those scripts were downloading their content in bulk. And that's that when those robots got to ocean tiles, they actually just kept on downloading them. So they'd see over and over and over again the same tile getting downloaded. And that was a really clear signal for bad activity and something that real users don't do. That let them build automation and update their WAF rules to block those bad actors when they detect them. So we built AWS WAF to provide customers with a simple to get started yet fully automatable WAF solution they asked for. You can use AWS WAF to block web requests based on IP addresses, string matches, SQL injection, or any combination of those criteria. Or you can use AWS WAF to monitor security events with new 1-minute CloudWatch metrics and alarms and sampled request details. In fact, actually, another one of our private beta customers was an internal Amazon site, and they didn't have a big need for the web security features of AWS WAF, but the visibility features and getting to see more details about how web requests were hitting a website were actually really interesting to them, and they started using the product just to get access to the new visibility tool set. AWS WAF launched with a new API and a new management console dedicated to web application firewall, rule configuration, and monitoring. And you can deploy the rules you configure to CloudFront distributions, which are frequently used by customers as part of their web application stack. Setting up AWS WAF is a simple 4-step process. It starts with creating a web ACL. A web ACL is the collection of your rules and conditions that specify what you want to allow and block, and it's the thing that we'll assign to CloudFront distributions. Within a web ACL, you tell us what default action you want to take, and for most customers, you'll want to allow requests by default. Then you'll add rules that that pair with request match conditions that lets you identify and block specific requests. And finally, as a 4th step, you'll assign the web ACL rules and conditions to your CloudFront distributions to start matching web request traffic. And I'll walk you through how that process works. So we'll switch over to my screen share. Okay. All right. So you can find AWS WAF in the security and identity section of the AWS management console right here. So we'll click in. And to get started, we'll create our web ACL as the first step. Once you've named your web ACL, we take you to a screen where you can specify your match conditions. And there are 3 different types of match conditions: IP-based match conditions, string match conditions, which inspect any part of the request headers, and SQL match conditions, which look for SQL injection attempts. We'll step through each of these, and I'll show you how they work. Starting with the IP match condition. So after we've named our IP match set, we'll populate this match set with a list of the IP addresses we want to match. In this case, these are known bad network ranges and no bad individual IP addresses. AWS WAF supports a CIDR notation, so you can specify individual IP addresses or ranges here on a /8/16/24 value or /32. So as an example, if we want to specify an individual IP address, we'd configure it like this. We'll specify all 4 octets, and we'll set a /32 CIDR range. We can add more. So if we want to block a bigger range of network addresses, then we'll specify a /24. So in this case, this would actually match any IP address that starts with 192.168.0. And that's up to 255 different address combinations. I'll create our web ACL, our IP set here. And I'll move on to the next step. On this screen, we'll configure the rules in our web ACL and pair the rules with the conditions. So we'll name our rule the webinar IP Blacklist, and here's where we reference the condition we just created. So in this case, we're looking for requests that originate from an IP address in our IP webinar Blacklist, and you can see this is it has the 2 network ranges that we specified in the previous screen. Okay, at this point, we have now our rule configured. We can assign an action that we want to take when a request matches that rule. And since this is a blacklist, we want to block anybody that matches this. With our rule configured, we need to configure a default action for any requests that don't match this rule. This is a public website. Most of our requests are good, so we'll allow them by default. Once I've created the web ACL, it's time to assign it to a CloudFront distribution. So for that, we'll head over to the CloudFront console. And I'll start from scratch on, we don't need to go through all these steps, but you'll notice in the distribution settings, there's a new field that says AWS WAF web ACL. And we pre-populate this list with the web ACLs you've configured. Here's our webinar web ACL. So when we create a CloudFront distribution, it will include our web ACL rule set, and we'll start filtering requests. All right, let's go back to the slides. A couple other notes on the our match conditions and IP match sets actually lets you configure up to 1,000 CIDRs per IP match set. And within a web ACL, you can actually configure a total of 10,000 CIDRs to match. All right. We've got 3 more demos that will highlight some of the other things that you can do with our match criteria. So for each of these demos, we're going to build on that basic web ACL we created using some real-world use cases that customers told us about. So in the first example it's called refer whitelisting. And in this case, this is a method that customers use to prevent content abuse cases. Specifically, let's say you're hosting a website that has many images, and you want your viewers to go to your website and view these images, and you don't really want other people hot linking and hosting your images on other websites. You can use refer whitelisting to accomplish that. So the refer whitelisting refers specifically to the refer header, which is a header value that well-behaved web browsers will set that indicates which website they're coming from. So in our example here, we've got a good user that's browsing to example.com and requesting content. Well, we can use that web browser behavior to create WAF rules that would just allow the refer header values we expect, the ones that match our website. And it would block all of the other ones. In our second example of a content abuse, fits some of the situations we've talked about previously, where somebody's created some script or bot to scrape all the content in bulk from your website. What often happens in practice is that automation leaks details or patterns inside of the web requests they're making. In our example here, the person that coded up this scraper bot actually set the user agent header to say bad bot, which is a pretty clear signal that this isn't a normal web user browser, this isn't a human, and it's a condition we can actually use to create a blocking rule. Something to note when you're creating rules like this is that the requester has complete control over how those strings and request headers look. And sometimes those attackers know that you're using WAF rules behind the scenes and will do things to try to evade your WAF rules. As an example here, our bad bot scripter may have figured out that we're filtering on their user agent, and to try to get around our rule, they've changed the casing of their string. So the string match sets actually provide a transform condition that helps you work around some of those evasion techniques. And here we can just lowercase that input value and use a lowercase match condition and still have the effect of the block. And then third, really in practice, when these kinds of things happen, customers told us that they don't often play the whack-a-mole game of trying to find patterns in the request headers, and instead one of the most effective means is really just simple IP blacklisting. So with that, we'll head back to our screen share, and I'll walk you through how to set up these 3 conditions. We'll start with the whitelisting of refers. So I'm going to create a new string match condition that specifies a list of the refer conditions that we expect to match our website. And we're going to create a rule that blocks anybody that doesn't match these conditions. So I'll give you a tour also of how string match conditions work as we go along here. So string match conditions let you select into any part of the request. You can filter your rules to specific HTTP methods like gets or puts. You can inspect the query string parameters, anything after the question mark up here. You can use the URI criteria to craft rules that are specific to specific paths of your website. And in our case, we're actually going to take advantage of our header inspection, and we'll specify the refer field. We pre-populate this list with some of the most common HTTP headers, but you can actually override this and set any value you want. So if you saw that there was some sort of custom header that was being passed in by the script, you can match against that here. Okay. And in this case, we provide you with 5 different match types. The most commonly used and the easiest to use is really the contains filter, but you can use other criteria to get more specific in your match criteria and eliminate the possibility of false positives. We actually created this list by inspecting the rules that are published through the open source OWASP Top 10 Core Rule Set, which is a list that publishes mod security rules for some of the most common vulnerabilities out there. And we went rule by rule and found how that rule set was actually matching and creating their signatures, and find that these 5 match conditions were actually the most used. So we provide them here in the AWS WAF with the goal that an AWS customer should be able to take any rule they find in the core rule set and implement it in the AWS WAF. For our whitelist refer, we're going to use the contains type. And we'll use a lowercase transform just to make this case insensitive. And then we'll match for my website. Now, in my case, my website actually has a .org and .net address as well, so I'll add them here. And the effect is that if a request matches any one of these 3, it'll be considered a match for the whole match set. All right, so now we have our new string match condition. We need to create a new rule that makes use of this new refer whitelist check. Okay, and in this case, I've actually specified, I'm planning to use a block action on this rule for any request that doesn't match my set of known addresses. We let you do that with a negating function here. So when I add a condition, I can actually flip the values, and we'll say when a request does not match the string match condition, refer whitelist, refer webinar block, then we'll actually treat those as matches. Okay, and as a final step, I need to add this rule into our webinar web ACL right here. So our webinar refer rule is here. We'll specify a block action. So now, whenever a request doesn't match that string match set, we're going to block it. And to create a condition that matches based on the user agent string, it's a really similar process, just a different header. So in this case, we'd be matching on the user agent and looking for bad bot. Same process. Okay, we'll go back to our demo, or sorry, go back to our slides. So we built AWS WAF to give customers lots of flexibility in how you configure or manage your rules. That means you can completely customize and actually combine your rule criteria together with ands or statements. We also give you the ability to reuse any part of your web ACL. So you can, of course, take one web ACL and assign it to multiple distributions, but you can reuse other parts of the web ACL too. And we think this is important because some of our customers told us that they're following a full DevOps service team model where infrastructure management and even security and rule management is delegated out to individual service teams. And in those cases, each service team will manage their own set of rules. We talked to other customers that have centralized security models where one security team is creating a rule set that should be reused across all of the other service teams. And AWS WAF supports either of those models with its reusability. We actually also support a combined approach. Because you can reuse components of a web ACL, you can delegate a portion of your rule set, as we have shown here, where web ACL 1 may be controlled by one service team and web ACL 2 is controlled by another service team, and they can customize these as they're developing their applications. But in addition to that, the security team wants all of the service teams to make use of their shared blacklist of some known bad vulnerabilities. And we can create one shared blacklist and have one place to update that applies to all of our other web ACLs that individual teams are managing. And in our fifth example, I'll show you how you can combine conditions together to achieve different types of, to build more complex rules. In the example I have here, you may have a web page like a WordPress site that has admin pages that are accessible through the public front door, but you might not want anybody and everybody to be able to get access to those admin pages. But you can combine together a string match set to filter for requests against the admin pages and combine them with an IP match set to limit the access to just the whitelisted IP addresses you specify. All right, we'll go to our demos again. We'll flip over to the demo screen. Great. So I'll start with an example that shows you just how to reuse an IP blacklist. It's actually pretty straightforward. Here's the webinar IP blacklist we created at the beginning of the demo. If I go back to my list of web ACLs, I've got a pre-configured web ACL here for my main site. And to reuse that shared IP address, just add it right here. Here's our webinar IP blacklist. And we'll set that as a block. Now, at this point, if I need to add a new IP, if I want to blacklist one IP address across all of my infrastructure, I only need to go into one place to do it, and that's right here. Here's our webinar IP blacklist. I can add one more blacklist, and it applies to both the webinar web ACL we just created and the marketing website web ACL. Something I'd like to point out while we have a list of web ACLs here, my pre-configured example has quite a few rules in, and I'd like to call out that the order here is actually pretty important. We process rules, web requests against the rules in this specific order. And the first rule that matches, that's configured with an allow or block action, is the action we'll take for that request, and we don't continue on with rule processing. And that's a bit different than this other last action, the count rule. When we find a match for a rule that's configured with a count, we'll actually continue on with processing and fall through to the end. So in this example, if we had a request that didn't match any of the first set of rules, but it did match our SQL injection rule, in this case we just count it, and then we'd fall through it and perform our default action of an allow. And as our example for the restricted admin page, we don't need to go through step-by-step replaying, creating the string match sets and the IP sets. So I've got it pre-configured, and just as I described, what we have down here is a string match condition that's matching on our admin login page, and that's combined with an IP match set that specifies a list of the IPs for our Seattle office. So when they combine together, both requests have to match in order for the request to be allowed through to our admin page website. All right, we'll go back to our slides. And again, when we built AWS WAF, we realized that really fast feedback loops are super important when responding to security incidents or just deploying new WAF rules. And what I mean by that is when you see somebody doing bad things to your website and you want to deploy a rule, you want that rule to take effect very quickly. So we actually built our configuration synchronization system based on the same technology that powers Route 53. And that allows us to synchronize your rule changes with all 53 CloudFront Edge locations in just a little over a minute's time. And that pairs with some new visibility features in form of CloudWatch, minutely CloudWatch metrics, and sampled request. So in the end, you can deploy rules and see their effect in less than 5 minutes. So you can quickly respond to incidents or changes when maybe your rules aren't behaving the way you want. You can revise them very quickly. The CloudWatch graphs that we provide, and that I'll show you, lets you quickly zero in on patterns in your web traffic. We give you rule-level details into what's matching your WAF conditions and your overall traffic patterns. And that pairs with sampled requests that are accessible right within the console that lets you zero in and see the exact details and headers and source IP addresses of web requests that are matching your rules or accessing your website. And this leads to the next example and demo that we have, which is based on a common pattern that we see lots of customers use when leveraging WAF technology. A lot of customers will actually run signature-based rules looking for vulnerability attempts like SQL injection in a non-blocking mode in an effort to prevent any kind of false positives from blocking legitimate user requests. But by leaving the rules in place and in a non-blocking count mode, that gives the security teams visibility into malicious events that might be occurring on their website. You can pair that with, or you can pair that up with our CloudWatch metrics and alarming mechanisms to notify your team when those kinds of events are occurring. And you can use sampled requests to pull the kind of details you need to really determine if that's a legitimate security event or if it's false positive. So I'll flip back to screen. Show you something I've been doing behind the scenes. So this is a curl command line tool. This is just generating web traffic. And you can see I'm making a request to my website, and I'm actually sending some badness here in our query string in the form of a SQL injection attack. I'm doing that just to generate some traffic. And I'll show you the rule we expect to match in our main site. We have a rule configured here. It's a SQL injection rule that's checking our query string parameters for any SQL injection attempts. And I just made some of those requests. I made a few before we came in here. And if I go to our CloudWatch console, I have our SQL injection rule on display for the main website ACL. You can see we're generating minutely metrics, and you can see exactly how many requests are matching matching this rule. And you can do this for any of the rules that are configured within the main site web ACL. Right within CloudWatch, we can create alarms based on this match criteria right here. This is useful for that pattern I talked about. This is exactly how you'd implement it. So whenever SQL injections are occurring, we're letting them through because we're worried about false positives, but we definitely want to engage our security team. So to notify our security team, we create our alarm. I think that in most cases, we don't expect a lot of false positives, so we're going to set a really low threshold here and just say if there are more than 3 requests that occur in a 1-minute period, we're going to take that as a bad actor that's probing our website and trying and testing us for SQL injection vulnerabilities. And our action will be to notify our security operations team. Right here. So this is an SNS topic that might send off to a distribution list, or right here within the console you can specify your own email address. And that's all it takes. Now at this point, anytime that we see those SQL injections, we're going to, anytime somebody like me is here poking around at a website, 3 events concurrently will generate an email notification to our security team. Okay, let's go back to our slides. Perfect. As I mentioned, AWS WAF was built with security in mind, and many of our internal teams and AWS customers are leveraging their own code to build more secure infrastructure. But it doesn't have to be, good automation, good security automation doesn't have to be super sophisticated. You don't need cutting-edge fraud activity tools to improve your security posture. And that's why I wanted to end the presentation with one more demo that highlights a very simple form of automation that can improve your security stance and response to security events. And it works like this. So it builds on that CloudWatch monitor and alarm we just created. Behind the scenes, CloudWatch is publishing those events to SNS. And instead of subscribing that SNS topic to just an email list, we can actually subscribe a bit of code. And in this example, I'll show you how you can use AWS Lambda, which is a serverless automation environment, meaning you can just upload your code into the cloud and we take care of the events. And with this configuration, every time there's a security alert and we see SQL matches, we can invoke this custom code that we've defined. And what I've set up is a sample that calls over to the AWS WAF API and grabs a set of sample requests before forwarding on the email to the operators. So it saves a manual step of going into the AWS WAF console and going through and looking at the sample requests in the UI. So to set that up, we'll take the alarm we just created. And I'm going to, actually I've got a pre-configured alarm here that really does the same thing, but we're subscribed to a different SNS topic, one that's titled Excessive Blocked Requests. And going over to the Lambda management console, I can create a new Lambda function. Within Lambda, we support 3 different types of runtime environments, Node.js, Java, or Python. And for my example, I'm just using some JavaScript, Node.js. And right within here, we can take our code sample and upload it. And as a quick walkthrough, I'm not going to step through every bit of this code, but the important bit that is worth calling out is the parameters that get sampled requests on the AWS WAF API expects. So for the sake of this example, I'm specifying a max items of 50, which means I'm going to grab up to 50 sampled requests on my API call. We also have to specify the rule ID and the web ACL ID. So in this case, this rule ID is our SQL injection rule ID, and this is the main site web ACL that I pre-configured prior to this demo. Then we pass in the start time and the end time, and in this code, I'm grabbing everything from now to 1 hour ago in that sampled request. You need to, I've set up my Lambda basic execution environment. I've given it permissions to both publish to SNS to send the email and to make a call to the AWS WAF API to get sampled requests. Once the code is uploaded and functional, all you have to do to make use of it is subscribe it to its event source. And in this case, we want to tie it to that CloudWatch alarm we created earlier, which was called excessive blocked requests. And that's it. With this in place, now every time somebody generates a bunch of bad request traffic, my security operator gets an email in their mailbox that says we're matching a bunch of SQL injection attempts, and here are all the details about the requests that are matching. So they immediately get to see the IP address and all of the header details for all of the requests that matched. All right, let's go back to our slides. Great, and with that, that's our introduction to AWS WAF. At this point, we'll cut over to questions.
So thanks, Nathan, for that presentation, and thanks to our audience for submitting some great questions. We've addressed quite a few via the Q&A pod, but unfortunately, we weren't able to address all, so we wanted to give Nathan some time to discuss some of these questions. We've lined up those questions for Nathan right now if you'd like to take a look, but again, I apologize in advance that we may not be able to get everyone's questions. We have about 15 minutes here, so please feel free to continue submitting questions at that time. So Nathan, let me pass it back over to you. You should see those questions in your queue, and go ahead if you wouldn't mind repeating those for our audience and then following up with an answer.
Great, I'll just take these in order. So the first question, if web traffic is encrypted using SSL, then how would AWS monitor the data packets hitting the web server? So in this case, our integration with CloudFront lets us inspect requests after SSL decryption has occurred because CloudFront supports SSL. With CloudFront, you can actually upload your own SSL cert or use the SSL cert that comes with cloudfront.net. And our integration point happens right after the CloudFront server has done the decrypt. Our actual rule logic runs on the same servers as the CloudFront servers. The next question, does AWS WAF require the use of CloudFront? Today it does, but we're always interested in hearing feedback about where customers would like to have this capability and rule set. The nice thing about CloudFront is that it can be used in front of many different websites, both dynamic and static. We have customers that use CloudFront in front of even REST APIs. Actually, in fact, if you're familiar with the API gateway, behind the scenes, API gateway is using CloudFront as the front end of their service endpoint. Another question, are there canned rules like block everything from some country? Today there are no pre-configured rules. AWS WAF lets you customize the rules however you like. There's another question here. What about geolocation blocking? Geolocation blocking today can be done within CloudFront. CloudFront lets you specify whitelists and blacklists of countries that you want to allow traffic from. And here's another question from Ron. Is logging available to see which rules are being used. For example, viewing a list of actual blocked IPs. Yes, the sampled request feature gives you all of the details about the sampled set of requests that are matching your rules. So you can absolutely see the blocked IP address. We also provide the country code for you and all the header information. I have another question. Is AWS WAF available through SDKs and the AWS CLI? Yes, it definitely is. The AWS SDK was exactly the thing I used as part of that Lambda demo to make calls from Lambda to the AWS WAF. Here's a question that's, can AWS WAF, can it be used to block direct ELB access? For example, allow only access through CloudFront. So I think what this question is asking is, can you configure your ELB to only allow requests coming from CloudFront? And the answer is yes. Today we publish a list of all of the CloudFront IP ranges, and that you can use those IP ranges to configure a security group that restricts your ELB to only receive requests from CloudFront. We actually, as part of this last reInvent, we've published a Lambda script and made that available to customers that takes care of that completely automatically, so that the script will just monitor our published list of IPs, and when those update, it'll automatically reconfigure your security groups for you. What is the difference between a WebACL and a security group? The big difference between a WebACL and a security group is what layer in the stack we're operating at. So security groups function at a lower network layer, and WebACLs are functioning at the web layer. So instead of inspecting packets, we're inspecting web requests, which may be comprised of multiple packets. And we've exposed a rule set that knows specific details about how the HTTP protocol works and inspect. I've got a couple questions asking about the code, whether or not we'll expose the code I showed today. I'd say probably not the code I showed today, but if there's sufficient interest, I think we can clean that up and publish a form of that customers can use as an example to build their own tools. And then the last question, are there any AWS third parties or partners which supports AWS WAF management and monitoring? Actually, yes, there are. We have a number of the leading solutions in the AWS marketplace are actually exploring integration opportunities with AWS WAF. They've published some notes on their blog, so that includes the Alert Logic WAF, who are looking at a way to integrate their AMI-based web application firewall with the AWS WAF rules to give you edge protection, as well as as Imperva, who has a set of reputation lists, and they've prototyped some tools that take their reputation lists and automatically update AWS WAF rules. So it's still early days. There's definitely, I think, stay tuned, and you'll expect to see some partner solutions emerging in the future. Okay, there's a question on pricing. So AWS WAF pricing pages are up and available, and the pricing model is it's $5 per month for a WebACL, and then $1 per month for every rule within a WebACL, and 60 cents per million requests that are inspected. The reasoning behind the way that pricing works is the request costs are tied to all of the rule processing logic that we have to do, the additional CPU usage on the CloudFront servers. And the WebACL and rule pricing is really mapped to the visibility features, providing those close to real-time CloudWatch metrics and the sampled requests on a per rule basis. Okay.
Excellent. Well, thank you, Nathan, again for the presentation, and we'd like to thank our audience for the questions. As I mentioned, we weren't able to get to all the questions, so we'll do our best here to follow up, but please continue submitting the questions. We really like to hear the questions as well as the feedback. Also, I want to give a last reminder to please submit responses to the poll questions that we put in the Q&A pod. We really do appreciate that. And again, thanks, Nathan, for your time and the great presentation. If you have any comments on a previous or upcoming webinars or suggestions on the topics you wish AWS will cover in future webcasts, please feel free to email aws-webcasts@amazon.com. And as always, your feedback helps improve our webinar programming. Thanks again for the audience for taking the time to join us, and enjoy the rest of your day.